Okay, today we're going to talk about graphical user interfaces, or GUIs. And a GUI provides a pictorial interface to a program. Now, in the days before GUIs, all programs were text-based. The interface was really based on these fixed-width characters and your screen having a maximum height and width. Okay, so we would write these programs, and we would have to kind of assume there would be a certain height and width of the screen. So we might say, well, there's 20 rows on the screen and maybe 40 columns. Okay, so basically all input and output had to fit within these bounds, within these fixed bounds. You still see these types of programs occasionally. The place where I get my car's oil change, for example, still has a system that's entirely text-based. Now, these programs require a great deal of code just to make the program presentable. And I've actually worked on systems like these way back when. We had tools to help us like this. We'd have there's this function called goToXY, where you could specify some row and column number. And basically this brings the reading and writing marker to some particular position on the screen. So you might say go to this row and this column. Now any C out or C in you do is going to happen, right at that position. Okay, so this is probably a little bit better than what we have now with our C++ console applications, our Win32 console applications. Right, with those, C out is always left to right, top to bottom. We can't even jump around on the screen. It's very difficult to get these types of programs right because screen size is a portability issue. So if one customer, let's say they have larger screens, they can fit 80 characters on a screen. Well, if you write your program to assume that and you go to column 70, well, if you have a small screen, havoc will ensue if you try and go to column 70 and there is no column 70. Okay, so what we've learned is that writing programs with a consistent look and feel is a really important way to make your program successful. Right, so we all are kind of familiar with this file, edit, view type menu system in just about every single program that we use. So I think it's time now that we learn how to create more sophisticated GUIs. And there's two packages in Java that we're going to use to create more sophisticated GUIs. The first is called the Abstract Windowing Toolkit, or AWT. AWT is an older package that's tied directly to the machine that it's running on, their underlying operating system. Okay, so if you write a program that will be run on a Windows machine and a Mac, and you create a button in this program, it will look like a standard button on each platform because it's basically using the operating system's window manager that's creating all these widgets. Okay. Now, although this sounds like it makes a lot of sense, Java programs are supposed to be write once, run anywhere, with a consistent look and feel. And not every operating system has exactly the same widgets available, so there were always some inconsistencies. One platform, Windows for example, may have some kind of widget that doesn't exist in another, say a Mac. Okay, so that's where the Swing package came in. The Swing package was built to be less platform dependent and more portable. The look and feel is more consistent from platform to platform. Swing components are written in Java. They use the AWT classes, but they might also use the Java's two-dimensional drawing package when necessary to make things look similar between platforms. So AWT is a thin layer above the operating system's windowing system. Swing is a more comprehensive abstraction. So you have to think less about the underlying operating system. AWT and Swing have code built in to create these things called widgets or window gadgets. And we've already seen one widget. We've seen the J option pane. Okay, when we use Swing, our applications are more likely to be consistent from one app to another. Okay, and the way we're going to get access to the Swing widgets is we're going to import the Swing package. Okay, so we import java.swing if you put the asterisk here, that basically says make all the widgets available in this package. Okay, so what does the hierarchy look like? Well, of course, everything in Java extends from the class object. Right, then we have these two classes, one called component, and then one called a container. Okay, component and container, these are from the AWT package. Okay. But then Swing, I said, was built really on top of AWT. So the root of the Swing package is this class called JComponent. Okay, and what we're going to find out is all the Swing classes start with a J. Okay, so for example, very shortly we're going to see this class called a JButton. And this represents just a button on the screen. Okay, so here's an example of, or here's the Java doc of the JComponent class. And we could look at some of the methods here. Oh, we could start maybe with the setters. So set visible, for example, that's a really important one. This makes the component visible or invisible. So there are some components that by default are invisible, and that you have to specifically say basically turn on the visibility for that component. There's one called set font. So if you want to have some text in your widget, you can set the font. And we have border. Each one of these things usually has a border. There's something called a tooltip text that's allows you to put some text over a component when you mouse over it. Okay, so there's a delay, and then after a second or so, some text shows up. Okay, so this documentation is going to be invaluable when learning how to use the GUI components in Swing. Now let's talk a little bit about kind of the best practices for building GUIs. Okay, applications should be built with a clear separation between the GUI classes and the application functionality classes. Okay, so we have our users, and they are going to interact with these things that we call boundary classes. Why boundary? Well, because they're on the boundary of the system. This is basically the code that the user is actually going to see and interact with. Okay, boundary classes then talk to these things called control classes, and control classes talk to these things called entity classes. Okay, so I'm going to talk about this architecture here. This has another name that you might have heard of called a model view controller architecture, but I'm going to use these names boundary, control, and entity. Okay, let's start with the entity classes. So entity classes model real-world entities. They are typically application independent. So in other words, they can be reused as is in many different programs. And usually these are the nouns in your system. So if our system has to do with students taking courses, we might have a student class or a course class or a professor class or a course offering class. All of these classes could be used in multiple applications related to students and courses. Okay. Then let's switch over here to the boundary classes. Boundary classes are used to model GUIs. Right? So we might have a boundary class called student login window, for example. And this obviously is what the student will interact with the student login window. Okay, and the student doesn't need to know about anything beyond the boundary classes. And then we have the control classes. Control classes coordinate the events needed to realize behavior. Okay, control classes are application dependent. They are responsible for controlling the flow of events. Okay, so we might have, our student user over here. And they might interact with this class called student enroll GUI or something like that. Okay, so this is basically a window class that has a bunch of GUI stuff that the student's going to interact with. Okay. This GUI class might talk to this controller called register for classes. Okay. And then the register for classes class may interact with an entity class, maybe called student. Might interact with another entity class called course. Okay, so again, the entity classes, these are the ones that can be reused over and over again in any type of application that has to do with students and courses. This class, this boundary class, is used for GUI stuff, and then it's the control classes that bind these things together. Okay, this is how applications should be written. The idea is that the GUI is the most likely thing to change in an application, so we want to isolate it from the business logic. So I call, in this application, the student and the course and all the real hardcore rules about how these things interact, I call that the business logic. If the GUI changes, we shouldn't have to change our entity classes. The entity classes should contain most of the algorithmic business rules and be totally immune or unaware of any GUI changes. Okay, so if the goal is to separate the GUI from the business rule heavy entity classes, there has to be something that sits in the middle and coordinates the data flow between the GUI and the entities, and from the entities to the GUI. And this coordinator is called the controller. If you do not take this approach and you change the GUI, so if you kind of mix everything together into one big class, then when you make the small change to the GUI, you really should retest all of your code, including the business logic. However, if you isolate the GUI and it changes, you'll know that you haven't broken any of the business logic, and that's an advantage. Now, you might ask, well, why do GUIs change more frequently than other classes? Well, GUIs are the only visible part of the system that our customer can see, and your customer will tend to be very opinionated about the GUI and will really have no opinion whatsoever about your algorithms or data structure or database design. Okay? They don't know about any of those things. The one thing that they can see and play with is the GUI. So it's likely that they're going to have more input on those classes than, say, your back-end classes. Also, GUIs are always evolving. Not only are there new programming models, Swing is newer than AWT, for example, there are new devices being created all the time. 10 years ago, there was no such thing as a tablet. Now they're prevalent. In 10 years from now, who knows what types of computers we'll be using? So think about your favorite sci-fi movie. However, the rules for how a student signs up for a course will probably not change that much. it really makes sense to separate the GUI from the rest of the system. In fact, many software development teams will break the team up into two parts, a front-end team and a back-end team, where the front-end team is responsible for the GUI and the back-end team is responsible for the business logic and the data structures. Most front-end developers these days focus on JavaScript, HTML, and mobile platforms like iPhone or Android apps. Most back-end developers these days focus on distributed server technologies like web servers and database servers. In the last couple of years, there have been attempts to combine the front-end and back-end technologies into what we call end-to-end frameworks. So, for example, Ruby on Rails, ASP.NET. There are several JavaScript frameworks, since JavaScript is such an important part of the front end. However, I find that most computer science people are not totally comfortable in both of these areas. Okay, so you tend to either be a front-end person or a back-end person. If you can do both, you'll find yourself to be very marketable. Okay, and that's kind of the holy grail, is somebody who can do both front-end and back-end stuff. Okay, although I'm emphasizing the separation of GUI from program logic, I have to say that I don't always follow the rules when building a desktop Java application. It's sometimes convenient to mix the GUI and the control classes together. However, I do really try to get the entity classes, make them separate. Okay, so how do we achieve the separation of GUI from program logic? Well, in Java we use event-based programming. And events are used to inform the control classes when a user interacts with a GUI component. So for example, when the user clicks a button or selects an item from a drop-down list, when they move the mouse, when they type into a text box. All of these things are related to how the program looks, okay, or gathering input, not how it works. Okay, none of the business rules are affected by this GUI stuff. So the standard event model is there is an event source, an event object, and an event listener. Okay, so let me draw a picture here. Okay, so the GUI component that creates an event is called the event source. So for example, if we're clicking a button, well, when we click that button, that generates this thing called an event. The event class has information about the interaction. Okay, so you click the button, it generates an event. An event is then handled by this thing called an event listener. Okay, so the event listener is informed when an event occurs. Okay, the event source, the GUI element, in this case the button, is used to register an event listener. So there's basically three steps to building a GUI. We create the GUI components, we register an event listener, and then we implement an event handler. All the GUI components that generate events have a method used to register a listener. So we'll see shortly that if we have, for example, a JButton, we could create the button like this. Okay, and then there's a method of the button class called addActionListener. Okay, and we'll talk about what goes here in a second. Basically, we have to tell it, what is the event listener? Okay, who should be informed when this button gets clicked? Now, what is a listener? Well, there's this interface called Action Listener. And it has a single method called Action Performed. So Action Performed. And this thing, this method takes a action event. Okay, so now any class that implements this interface guarantees to provide some kind of implementation for the method. So when an event occurs, a GUI element can safely call this method on the listener and have it respond to the event. Okay, so we will have this action listener interface. And I'm going to maybe imagine creating this class that implements the listener called a button handler. Okay, so the button handler implements the action listener interface. Okay, now when a button is pressed, the button handler object will be notified. So we would say something like this. Okay, so we have this public class called button handler that implements the action listener interface. That means the button handler is guaranteed to provide a method called action performed. Okay, and what's going to happen inside this button handler is it will handle the button press. So this is a classic controller that sits between the GUI and the business logic. So when the button is pressed, the controller would then do something, maybe create a new student object or create a new course object. Okay, and then somewhere else in the code, we might have something that looks like this. So we'll create this button handler reference called handler. We'll actually create the button handler object. And then when we create our button, we will tell it who to send the events to. Okay, so here's where we have to fill in that parameter in the add action listener. Okay, so we've created a button and we said, all right, when somebody clicks this button, we want to notify this handler, okay, this class that implements the action performed. Okay, so this is the event source. It generates the event. Okay, the event is here passed into the handler, and then this handler then responds by doing something when that button is pressed. Okay, now there are different types of event listeners. Event listener is as an interface, and here are some known known sub-interfaces. So action listener is what I just talked about. Action listener is used to enter in text in a text box. It's used to respond to that. It's used to respond to button clicks and a few other things. There are a few other ones. There's something called an item listener. An item listener listens to selection of things like a radio button or a drop-down list. There's this thing called a mouse listener that listens for mouse up and down events when you click your mouse. When you release the mouse button, the left and right, both the left and right buttons. There's something called a mouse motion listener, which can be used to track mouse movement. And there's something called a window listener, which is generally used to override the behavior of when you want to, say, close a window. You can make it do something different, like maybe just hide itself in the background. Okay, so coming up next, we'll talk about more specific uses of the Swing library, and I'll show you several different examples of Swing classes.